quadratic? No, 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 no. A quadratic, you may be thinking. I know a quadratic. A quadratic is an ax squared plus a bx plus a c. It's not a quadratic because quadratics have x's and this has e's. What if I was to change it to be au squared plus bu plus c? Still looks like a quadratic, but guess who u is going to be? Can e to the x be squared? Yeah. E to the x can be squared. And what happens when you raise a power to a power? X times 2 is 2x. Oh my goodness, it's a square. Minus 5 times e to the x plus 6. Oh, in math, if you ever don't like how it looks, you can actually kind of make it a different variable. Doesn't always help tons and tons, but in this one it might, because this one we could say, hey, it's u squared minus 5u plus 6. You can totally ignore the e to the x for a little bit if you want to. How would you solve if I had given you this at the beginning of class and not that? Yeah, and you would have gone ahead and thrown in the 6 and thrown in the negative 5 and hopefully figured out negative 2 and negative 3 are a possible combination of both. You would have gotten a u minus 2 and a u minus 3 equals 0. You could have even kept going to say u equals 2 and u equals 3. But we're not supposed to be solving for u. We're supposed to be solving for x. So who was u? Couldn't we make this e to the x minus 2 based on what we kind of did in the very beginning? And some of you can actually jump from here to here because your brain's like, oh, it's a square. I got it. It's okay, got it. But some of you might need to actually get yourself out of this problem into u's and then come back. You might need to kind of detach a little bit and then get the e to the x's back in. But this actually would lead us to not u equals, but e to the x equals 2. Or e to the x equals 3. How do we get to x? Yeah. Does that make sense? Throw in that ln. Throw in that ln. Isn't the e now gone? And we just have x equals ln of 2 or ln of 3. There were no logs to begin with, so the whole extraneous domain problem thing isn't even an issue. Dun, 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 dun. It looks, can you make it look different for a little while? Do you have to eventually come back to the actual meaning? Yeah. But then just set each equal to 0, use some ln's, and dun, 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 dun. Who got there before me? Give me a thumbs up. Oh, not everyone, after all. If you think maybe you kind of get it now, give me a little, like, hand wiggle. All right. All right. It is on the video. You guys can check it out. That was a quick little just extra hard type of problem from section 3-4 that no one asked about yesterday. All right. You guys have these models in your notes, but the big thing on everyone's mind is how do we do homework, right? All right. So let's figure out how we do homework. You guys ready? If you want, if I were you, I'd open up your books to page 245. We're going to do some examples in our notes to help you directly with homeworks out of the actual sections that you're tackling, starting with, oh, look, they actually gave you the formulas you need in numbers 5 and 6. Anyway, you just wrote them down in your notes also, and you were able to take a picture yesterday. Problems got hard starting in numbers 7 through 12. Anyone with me? Problems got hard starting in numbers 7 through 12. Now, you're not supposed to be writing in your book. So even though I'm going to maybe write some things in my book, it might be helpful for you to write them in your notes. True? Okay, for the first section of homework, I would say hint, homework hints. Okay? Homework hints. Starting with numbers 7 through 12, talking about compound interest. Let me give you some clues about the wording, okay? What do we see in this table? Let me get this guy back up. We see initial investment, annual percent rate, time to double, and amount after 10 years. Let me help you out with the math of what those column headings actually mean. Okay? Initial investment. Now hold on, wait a minute. We're using formulas, right? Like these interesty formulas that you guys just wrote down that looks like these two, right? What type of interest is this? Is it going to be the PERT formula, or is it going to be the messy one? If it says continuously compounded, what do your notes already say for this? Which one? Good. It's going to be number 5. It's going to be the PERT. Continuously compounded. That's PERT. Okay, so let me go ahead and write that PERT formula. So for number 7 through 12, you're only thinking, first of all, A equals PERT. E to the RT, right? Okay. Let's talk about those column headings. The first one says initial investment, right? The second column says annual rate, true. And does it give you a percent? You guys have it open, right? Is it percentages? Cool. The next one says time to double. And the last one says amount after 10 years, right? Let me give you the math. The initial investment is talking about P, the principal. How much money was put in? P from the formula. The annual rate, R, is going to equal the decimal equivalent. You guys know what I mean by that, right? Make the percentage into a decimal. Time to double is going to be T equals blank. They're giving you T's when A equals the amount you have is double what you began with. The amount you have is double what you began with. And then last but not least, A after 10 is A such that T equals 10. Is A such that T equals 10. So what I'm talking about is that this could actually be function notation, the amount after T years. I'm going to help you so much, I'm going to say, hey, what's one of the homework problems? What's the first one I asked? Number 7?
Yeah.
Okay. So let's go ahead and play with number 7. If you guys had your homework all the way ready to go, you can turn to your homework spiral and do it there. I don't mind. Or check it there. You don't have to do it in your notes. So if you have your homework spiral close, I'm going to do number 7, literally the whole thing. So maybe you're checking yours. Maybe you're putting it in the back of your homework spiral to have it ready. Maybe you're just putting it in your notes to have it ready. Number 7 gives us what clues? What's the initial amount? $1,000. Put in $1,000. So what's the rate for the account? 3.5%? And then are the other two missing? Okay. So let's go to our formula and say, all right, we know A is equal to 1,000 e to the 0.035. You guys see what I did, right? Moved my decimal 2 places to the left. 0.035t. Booyah, I have my formula ready to go. Why? Because I need to use it for these 2 boxes. I need to use it for these 2 boxes. Okay, the first box, time to double. What am I going to make A? 2p. I'm going to make it 2,000. E to the 0.0. Wait a minute. So what are we supposed to be finding? Find t. Is that something you guys should be able to do with division and ln both sides in division? Using your calculator? Yeah. What's going on for this box? Plug it in, plug it in. Yeah. Now, wait a minute. After 10 years, is it going to be doubled? Do I know that? Oh, I don't know what it is. I'm supposed to be finding. So I'm going to say A of 10. I need to find A on this one. So in this one, I'm going to use the same base formula with the 1,000. E to the 0.035 times, plug it in, 10. Hey, isn't this just a plug into your calculator problem? Thank you. That's just a plug and chug to your calculator. This one's going to be dollars, and this one's going to be years. Oh, well that's not too bad. What's another one that I asked you for in that section? It got worse. Number 7 was an easy one. Number 10. I'm not going to do the whole thing, but do you want me to help you set it up? Number 10. I'm actually going to go here because we have our nice table ready to go. Number 10. Lacey, do you have the given info? Okay. Ooh. That was the problem. They gave us nasty information. So we're missing the rate, which is a bummer because that's a really important variable in our equation. We're missing time to double. And then, sorry, what was the amount after 10 years? 505. Okay. Whew. All right. Well, we still have something to plug into our formula, though, right? Guys, who am I going to plug in? 500 is my initial investment, but I don't know R. Well, T is always changing. It depends on what I'm looking at, but I don't know R or T. Okay, because T is supposed to stay unknown. That's all right. But R is not supposed to stay unknown. But wait a minute. I know more than 500, don't I? What else do I know besides 500? Okay, yeah, I know the 1505. So let's go ahead and apply this guy. We have to, don't touch him, because this is what we need to be plugging in. But we can go ahead and say, all right, what do we know here? Well, wait a minute. We know that this is after 10 years, right? So can't we say that A of 10 is equal, we know the number, 1505, which equals P, oh wait, we know P. P is 500. E to the, oh, we don't know R. Oh, but we do know T. Hey, if we just plug in our clue, what are we going to be finding? Yeah. And once we find R, what can we do with R once we know it? And then once we know R, can't we go ahead and do the same clue we did here? Once we know R, this was easy. Double it and solve. So we're going to use this clue to solve for R. How do we solve for R? Oh, division, ln, division. You're going to have R. You're going to be able to put R into the formula. And once you put R into the formula, use the exact same procedure as we did for number 7. As we did for number 7. Now, kiddos, I'm not saying that that's the entirety of this section. The time to double gets a little weird, but you're going to see him actually other places in homework. So let's keep going. Let's keep. Didn't you have a problem? Was it number 15? That was it. Formula am I going to be using? And I can actually, so we can see him. Which one am I going to be using for annually? Well, pause. Where's Pert? Oh, he's not until letter D. Okay, so what do you think this and this and this all are? It's the other one. Well, annually, hold on, what does N stand for? P is the principal, how much you start with, R is the rate, T is time. Who's N? Number of times per year. If this happens annually, how many times per year? Monthly. 12. Daily. So you're taking your info and you're plugging it. Wait a minute, we don't have very much info. We don't have very much info. We don't even have principal. 15. Number 15, we know what formula we're using, like for letter A. We know that N is equal to 1, and we're using the formula A equals P. Double check me that I'm writing it correctly, but I think I have it down. They're asking us in directions. It would have been very important for you guys to figure out the time it takes to double. Double check me, for those of you that wrote the directions. Is that the main gist? The time to double when? In number 15, what did they tell me was R? So what can I plug in? Well, I can plug in. I don't know P. That's lame. I do know N. For A, N is 1. Haha. I do know R. R is 0.10 because I have to move the decimal places, right? I know N. I don't know anything. I don't know T, and I don't know P, and I don't know A. Wait. What did we just say double meant? So can't I set A equal to 2p? Actually, just forget that. Time to double, A should be 2p. Well, I don't know p and I don't know t. If there's a p on both sides being multiplied, what can I do? Does p even matter?
No.
No. What matters is the ratio of ending to beginning. So whenever they say time to double, even if you don't know what you started with, you can actually say, well, I don't know what I started with, but I know this guy is double, and when I divide, I always get 2. 0.1 divided by 10 is just 0.1 to the 1t. Should we be able to solve for him? Could we use a log base? Could we use ln's and bring him down and divide? Hopefully. But all you gotta do is find time. So double meant make A 2p, divide by p, and he's gone, and all of a sudden it's something that you can solve. Kyle.
Can we use that same formula? Like, let's just plug in the n each time?
Yeah, all that's going to change in letter B is that n is now 12. So come back here and say, well, the rate's still 10, just this is 12, this is 12. For letter C, 365, 365. And for letter D, I have to go back to PERT. Oh, wherever PERT is, he's up here, isn't he? But for PERT, can't you do the same thing of 2p and the p's still go away? It's just going to look a little different. Oh, I can finish this one, Robbie, since it's letter A. You can take, remember, I can put in anything I want. I didn't like to do log base 1.1 because it just sounded gross to me. So I said ln's nicer. And what happens whenever you take a log of something with a power?
You can
Power down, right? Ooh, hey, I like it, power down. And I get 1.1. Robbie, how do I solve for t? Divide. Plug into your calculator. So t is going to equal ln of 2 over ln of 1.1. Plug it in. I'm guessing years. I might be totally wrong. Depends on the situation as to what's going on. If it's investment, though, yeah, it's going to be years. Okay, does that get us through all the interesty stuff? Most of it. Where does homework go after the interesty stuff? Oh, Austin, I'm sorry. What's up, bud? Yeah, definitely. It's also on the video. Oh, sorry, some of this is going to be... Oh, no, you can see it all. Yeah. Let me get my hand out of the way. Yeah, you guys can have phones out and take pictures along the way. That's fine. It's also saved in your class folder on Google Drive. It's also in the video. But yeah, it's fine. Okay, where did homework go after number 15, after the interesty stuff? Oh, radioactive growth and decay? Yeah, it did. Hey, do you guys have some formulas that you just wrote down a second ago in your notes that had to do with growth and decay? Yeah, you did. Okay, is it over in this table? Is this the next hard part? Okay. Looks like they didn't give you very much again, but they actually did. So now we're in exercises 21 to 24. Okay. And specifically, if you guys look at it, is it growth or is it decay? How do you know it's decay? It's cutting in half. It's not doubling. Doubling is growing, like if something doubles. If something cuts in half or is half of its original amount, it's decaying. And don't we want radioactive stuff to decay? Yeah. Okay, coming back. Amount after 1,000 years, there's still some left. Chemistry. Anyway, coming back. So in this one, we're talking about decay. And with decay, it's really helpful to have a model. Decay is going to look like y equals a e x. That's what your notes would say. I'm going to make it a little bit different. I'm going to say a is equal to p e to the negative r. Oh, what did I just do? Blasphemy. I stole the finance equation. Why? Because you know this is how much you had at the beginning, right? We can apply that to radioactive growth and decay. What was the initial population? We know this is a rate, some sort of weird decimally thing. We know this is time, and we know that is how much you have now. We can use that idea. What's different? The negative. Why? Because it's shrinking, not growing. So help me out with the actual, okay, pause. Your table starts with its name. Do we really care about the name? I mean, Mrs. Leon would, yes. But do we for the math? What's the next column? Half-life. What's the next column? Initial? What's the next column? After what? 1,000? Okay, let's talk about the math then. Ready? The name, mathematically speaking, has no bearing on us. We're just dealing with the data. We're like the number crunchers. Half-life is going to be the t equals when a is equal to 1/2 p. It's like doubling, but half. Initial, oh, that's just p. Amount after 1,000, oh, that's just a of 1,000. Oh, that's not bad. That's not bad. What's one of the ones I give you guys then? No, what number? 21. Okay, what's the info in there? $15.99 is half-life. So that's actually in years. That might help us out as far as T. Do they give us initial? What's in that column? 10 grams. And then I'm guessing this one's blank? Okay, so let's plug in. All right. Our formula, A equals 10 grams times e to the, oh, we don't have a rate or a time. Oh, but wait, don't we have this clue? Okay, well, let's use that clue with the formula. We know, half-life. We know that A is 1/2 p. Oh, who's p? 10. Oh, so we could just say 1/2 p is equal to p times e to the negative r times 15.99. We could just do that and forget the 10 and not even think about them. Or we could be super snazzy and say, oh, but we know it's 10. So this is going to be 5. But either way, whether you divide by p or whether you divide by 10, what are you still going to get over here on this side? Yeah, you're still going to get 1/2. It doesn't matter which way you go. We're still going to end up with 1/2 equals this mess. Well, guys, mathematically speaking, should we be able to solve if we have something stuck in an exponent of e? Yeah! What are we going to do to both sides? ln it. Of course we are. Because what happens with ln of e? Whoosh. Gone, gone. I get negative 15.99r is ln of 1/2. Guys, that's a simple division now, right? And what happens once we figure out what r is? Can't we come back and say, ah, ha, ha, we figured out who you are? And once we figured out who that is, maybe it's not so bad just to plug in 1,000. What'd you get, Kyle?
1.335.
That's going to be the percentage?
The -4x.
Oh, to the -4. That's a mess. Remember scientific notation. We have to move it over to the left, right? So that's going to end up being 0.0004. Give me a few more.
Nice.
Then we can put the r in and we can go ahead and solve. If that r is correct, this isn't odd. You guys can double check. But is it a little different, Gavin? Oh. Do you have a question? Okay. But do you see how we're playing with formulas, guys? Now, once again, why is homework hard? At the beginning. Because it doesn't give you the formulas. You have to figure it out reading the directions. Decay? I don't know. I'm not a radioactive expert. Well, I just showed you exponential decay always starts with the same type of equation. And I made it more understandable for you using the financy stuff. Yeah? Yeah. You can, and we did because we knew what initial was. We knew it was 10, so we said, oh, that's going to be 5. But even if we didn't know we can divide by p, it doesn't really matter. And it still becomes 1/2, which is what we could have done without even knowing. In some problems, you don't always know, so that's why I'm trying to show you that. Where does homework go after the radioactive table? Ugh, that table was gross. This table was gross. And then you play with graphs for a little bit. Okay, cool. Whatever. What's next? Okay.
Ew,
Okay.
disgusting.
Okay. Number 30. I want you guys to go ahead and, even though it's a great question, because it's actually super interesting. Now, it is using projections from 2010 going to 2020, but it's showing us that basically we're not alone in the world. Remember, more often than they do. But anyway, coming back. More often than many do. I generalized that statement. That was not an absolute in any way, shape, or form. Just you guys might not know me well enough to know that that was not an absolute statement. Coming back. This is a very interesting problem, but it takes a lot of work. I want you guys to make a note in your homework really fast. If you want to try number 30, do it at the end of homework, and it's going to be extra credit. If you want to do number 30, do it at the end of homework, and it's going to be extra credit. Why? Because you have to put together this data, this information, 2 different times for every single country to go ahead and solve. Now I can show you a quick little peek as to the math, because the math is actually quite easy in some ways, shapes, or forms. In some ways, shapes, or forms. They tell you this is exponential growth or decay. Some are getting bigger, some are getting smaller. But long story short, we can still basically think of PERT. Growth or decay. Yes, I know it's negative for decay, but R can be a negative number or a positive number. It actually works out either way. Here's the dealio. They don't tell you initial, they don't tell you final. They just tell you what's going on in 2020. So we could let, for instance, oh look, they're doing the whole cool trick from the beginning of the year. Don't use 2000s, use 10 as years after. Let year 2000 be 0. So we could say, hey, when time is 10, let's just use Bulgaria as an example. When time is 10, I don't know its growth rate, but I know it seems to have 7.1 million people. But I don't know R and I don't know P. Oh, but wait. Couldn't I also say what was going on in 2020? Wasn't it 6.6 million people? Oh, isn't it just a little baby system of equations? 2 equations, 2 unknowns. We should be able to do that. For instance, you could go ahead and do something like, isn't P going to equal 7.1 over e to the 10 R? And couldn't we plug and chug? And so couldn't we say 6.6 is equal to 7.1 e to the 20R all over e to the 10R? Oh, how do I do like bases division? I subtract. Oh, so that's going to be 6.6 is equal to 7.1 e to the 10R is left over. Can't I solve for the growth rate of Bulgaria pretty quickly? Dividing using ln, dividing by 10. Is this going to be a positive growth rate or a negative growth rate? Yeah, it's decreasing. And what do they want me to do? Just figure out its growth rate? No, they're also curious down here somewhere as far as what's going to be happening in 2030. They're curious what if the trend continues, what's going to happen. Is it ever important to think of trends and how different things are happening in the world and populations? Yeah, that could be very helpful for all sorts of institutions. All sorts, right? Just giving you a little bit of practicality. But do you guys realize how that's just letter A and it's going to take a while? The math isn't that bad, but it's just letter A going to take a while. So number 30, do at the end of your homework. What goes after 30? That's the longest, hardest as far as brutal, like grueling, tons of work to do. What's after that? 31. Well, it's word problems, but look, it's not an ABC, right? It's not an ABCD. And they give you the nice little baby equation to use. Well, that's kind of cool. Oh, I'm missing K, though. But what do they tell us somewhere in the problem? A clue. If T is months, after 3 months, how many hits? So can't I say when T is 3, the amount is 10,000? Couldn't I solve for K?
Yes.
After I solve for K, couldn't I then plug in and have a new model where I can plug in 24 months and see what's going to happen? These are, in a sense, more short and sweet. Does that make sense? So if you can get through the nasty 2 tables, that I do believe I gave you quite a few hints. And if you can, skip number 30. Then you guys can focus in on the bulk or the main point of homework, which is seeing, can you read, take a model, plug and chug, and find what you're being asked for. Does that make sense? All right. Take it away, cool kids. Still due tomorrow like it technically always was, but now you have many more tools to play with. Many more tools to play with. If you finish this early, start reviewing. Definitely.